Hi, Nathanael Coffing here with Authenticate2020, here to talk about FIDO, CIBA, OIDC, and OAuth, how they all work together to build this adaptive dynamic authorization for customers. I'm with Cloudentity, and we're going to walk through all these net new standards coming down the pipe and then how they interoperate, right, to provide net new features and net new functionality for things like open banking, GDPR, and the next generation of dynamic data sharing between businesses. So I want to first start with just a baseline. Let's make sure we all understand what the different standards do, right? So FIDO, right? We're all here because of FIDO, specification for authenticating users to online services without using passwords. That's the key there, right? Getting us past that UID password. I call it a trap, but it's been so pervasive that let's not go down that tangent. OAuth, it's a delegated authorization framework that was released in 2011 for RESTful APIs and applications. And this is important because all of our next generation of services are really wrapped around APIs, right? That's how we're communicating with external third parties and between internal products, et cetera. So being able to build in authorization into APIs becomes a fundamental aspect of how we're securing our next generation of services. OIDC, it's a simple identity layer that sits right on top of that OAuth 2 protocol, allowing clients to verify the identity of the user. And then CIBA is a relatively new standard that also piggybacks on top of OAuth called client initialized back channel authentication. So it's a method of querying during the course of a transaction out for third-party authentication. So as I alluded to earlier, modern applications are almost entirely composed of API-driven cloud-native services. So if we look at where we were 5-10 years ago, it's on the left-hand side, this kind of on-prem VMs, very big monolithic application stacks that are comprised entirely in a singular VM. Now, as we move into the next generation of cloud-native microservices, what's happening? We're taking that user interface and that business layer, we're breaking those into microservices. Those microservices then are intercommunicating in what we call east-west traffic, right, to provide all that business interface, data sharing, et cetera, on cloud, across clouds, and even between on-prem and clouds. So the important thing to note is that each step between those microservices, authentication and authorization must occur. That security, our security layers are entirely provided by authorization and identity at those individual API endpoints between microservice and data layer. In the old world, it happened right at the front door in the user interface. In the new world, it's happening in between each step of a service, particularly in multi-step transactions. So we have to start thinking about what are our basic requirements from an identity and authorization perspective for each of these independent services. And we've taken the time to break those out, right? We need to make sure that we have that user identity token that comes via OIDC. We have the service identity that comes via SPIFFE. We have a request authentication and authorization. That's course level. That's kind of our old way of doing authorization. What can a user do in an application? We have an API validation, right? Is it actually matching the contract for the API, making sure that there's not something like SQL injections or JSON logic bombs. Then we have a much tighter level of authorization, this OAuth 2 scope validation with dynamic authorization built in. This gives us some flexibility as part of net new OAuth 2.1 and beyond standards for intent-based authorization or dynamic scopes. Next, we have that requester identity validation. Let's make sure not just that I have that token, but that they used what we call an AMR, an authentication request that is appropriate for the authorization required. Lastly, we have authorization at the data object level, meaning not only is it what can a user do in an application, what can an application know about a user, but what can an application see about a user or share about a user to other applications. Lastly, all this has to be wrapped up in immutable authorization for consent, for logging, for exactly what transpired within that business function. And so if we look at what's happening today, right, we just see a massive sprawl, and this actually came from one of our customers, of identity providers, authorization, authentication, and privacy. And if we just take a couple of these, we see that we have authorization happening at a coarse grain with a Duo-based authenticator. We have authorization happening at medium grain with a FIDO-based authentication. We have authentication happening machine to machine with we have authorizations happening machine to machine with no authentication. And we have things that are home built. And all these pieces have to work together, right, to secure a transaction across our cloud native services. Makes it increasingly difficult increasingly hard for customers to maintain, and really impacts both our ability to be agile as a business and our ability to engage our customer base. So normalizing on things like FIDO for authentication, right? OAuth for authorization, machine to machine for passing user or requester identities becomes increasingly important as we see the sprawl of these services across clouds, across VPCs. So taking that and going just one level deeper, right? The question is, do we snowflake or do we standardize? And I'm a big fan of standardization, right? If we build that standardization, then we're able to build applications much faster. We're able to build guardrails for our developers so they know exactly what they're supposed to do instead of kind of building independent snowflakes. And again, this is just a really simple example where we're taking just a known attribute called email, and we're looking at how it's treated differently across 3 different APIs. On the first, we see that it's called mail, right? And I have a scope grant for read mail. In the second, it's an invoice. I have a scope for read email. Now, obviously, these are the same attribute. However, they're being treated differently by the application developers. So what do we need to do? We need to start normalizing both what the scopes are, what the attribute names are, and what the authentication, the MR record types are. And that is really the whole point of this, is how can we start to standardize, normalize, and add a level of governance on top of our different services to ensure that there is a well-known pattern for developing net new services and developing integrations. This reduces our overall attack surface, it reduces our overall concern, makes our regulatory compliance requirements much easier. So this becomes an imperative, particularly as we move into these modern multi-dimensional multi-cloud services. And all of that is what we call normalizing authentication and authorization, right? So bringing a harmony to it, right? And it's important that we don't start by saying, hey, let's rip and replace. I think anybody who's been in the identity landscape has already experienced that. And that's a failure from the start. Meaning you've got to leverage what you already have. Your companies or organizations have spent, millions, if not tens of millions, trying to bring in different IDPs, building out, that sprawl. So how do you start to integrate with your existing IDPs, your existing API gateways, and your existing authenticators? How can you also normalize privacy and consent, right? This is becoming a bigger and bigger deal in Europe as well as in the United States underneath GDPR, CCPA. And in fact, we're actually seeing things like open banking start to regulate how privacy and consent is being treated across your different services, both from a user experience and management perspective, as well as from a reporting perspective of what's going on from a governance. That all leads to centralizing that policy management and governance while having distributed policy decision and distributed policy enforcement, all normalizing underneath common standards. Again, authenticating with things that are best of breed like FIDO. Now, it's important as we think about this that we prepare for scale. And if we look at how we built identity in the past with monolithic architectures, well, what's happening? Well, I go to the IDP, that's kind of been this big monolith that authenticates, authorizes, and then passes me off. Now, if I want to enhance that authorization, if I want to have these distributed policy decision points, then have additional steps in the transaction. I either have to call home back to the IDP, or I have to call to a relatively closer, hopefully, PDP. But it becomes very expensive from a transactional point of view. If my service has to find out what am I allowed to see about a user during the course of the transaction and has to call an external PDP, it has to hit the wire, has to get the response, has to pass the data, and then receive everything. What happens? Well, delays. We all know delays cause user loss. It's a bad user experience. So if I look on the right-hand side at what's happening in the cloud native architectures, well, I have an authenticator. I've separated apart my authentication context from my authorization context. So I turn a 5-step transaction into a 2-step transaction. I get my authenticator, and then I go straight to my services, which have localized PDPs. And because of that, you're able to reduce your overall latency, right? Move it from being 100 or 200 milliseconds, depending upon your network lag, down to sub-millisecond latency. You're building out distributed authorization, distributed authentication checks at the distributed service level, right? So you're able to scale with your distributed services instead of trying to scale it centrally within your singularized IDP. And that's really where we're seeing this dynamic authorization becoming that center point, that crux, that nexus of how you're going to build security for your APIs and your API-driven services. On the left-hand side, again, we have all the different contextual data types, right? We have our IDP context. How do I authenticate? What roles am I in? And what groups do I have? What policies are applicable to me? I have my privacy landscape. What are my regulatory requirements under CCPA or GDPR? What are my regulatory requirements if I'm building privacy by design into my applications? Then my open data regulations, right? And it's not just open banking. Open banking is really the first thrust. It's also open transport, open telco, open energy. Everybody's moving to this API-based economy, and they're forcing that contextual data into your authorization normalization, and then pushing that down to as authorization as code, which is what we like to think of it as, so it can coexist, be co-located with your applications. So as you're undergoing that cloud transformation, that application modernization, building out microservices, you're able to actually start protecting those microservices in real time when those services are spun up. You're also starting to focus on what data is getting released, what we like to call data lineage, understanding what service, what workload, what machine saw what data pieces. And so you're building an implicit, or actually an explicit transparency to your users as well as to your regulators of service A saw the full user record, service B only saw a first and last name, a subset. So in the event of a breach or in the event of a regulatory compliance reporting, what are you going to do? Well, you're going to report on the important services, and you're going to be able to say exactly what data each service and each service instance saw of that. So it makes your reporting lives much, much easier. Also easier to find and parse out anomalies in transactions. So as part of that, there's a standardization, right? How do we start to externalize our authentication authorization policies away from the service? And we're doing that through scopes, through dynamic scopes. Being able to tie rich policies, as you see on the right-hand side, of what should my AMR look like? What does the scope mean? How is that scope and grants, how are they based upon a much more robust policy language to the actual execution of that at the service edge? And so you're able to leverage both, can service A talk to service B? What user and authentication context should look like? What PAI data is allowed down to those independent services, and then even going so deep as what data objects can a service see, what are the entitlements functioning for those services, and wrapping that all into a common authorization platform, trying to make it as easy as possible for developers to adhere to corporate guidelines without overburdening them. In fact, you're releasing them of a lot of their responsibility now that they can just subscribe to the appropriate policies. Of course, as part of that, it's all about managing it centrally, distributing it globally, right? So if we look at the left-hand side, yeah, it's great, if we're building these policies, but if we don't centrally manage them, then it's being pushed onto the developers. And what happens? Those developers across different BUs, well, anytime the CISO or the DPO has to go and find out what services are exposing PII, for example, they actually have to get into the code and say, hey, developer X, can you tell me what are we using in this service? There's also a problem of compounding failures. And what I mean by that is once that data gets down to the service, what that service does with the data becomes increasingly difficult to trace. Maybe they push it into syslog and it goes out to the SIM. Now your SIM becomes a honeypot, right? Or maybe they're pushing it into application logs or storing it somewhere locally, but that data gets propagated, almost exponentially if you don't control that data lineage. With centralized authorization, what do you find? Well, one, I know when my services spun up. Two, I know when those policies were applied to those services. And three, anytime there's a change in policy, for example, let's say shoe size becomes PII data, now I put shoe size in as a sensitive attribute, and I republish those policies dynamically in real time. And those policies are instantly enforced across all of my services, regardless of the underlying application infrastructure. Again, supporting things like API gateways, microservices, service meshes, Kubernetes, and functions. So what does this look like, from a little bit more of a real context? Well, we have the IDPs, right? We have our authenticators that are responsible for managing different aspects of the user journey, different data about the users, et cetera. And this is, where the Oktas, Auth0, 4-drop pings, have a very strong swoop. So they're authenticating, right? And then they're passing that data, separating out that authentication context away from the authorization context. This is, again, exactly what OAuth was designed to do, separate authentication from authorization. So then they get past what we call that AMR again. How did that user authenticate? When did they authenticate? Data like that, they pass that down to the authorization control, plane. That authorization control plane then makes the determination of, okay, is that data, or ties that identity context to policy context and pushes it out to your different policy decision points. And again, being that security gateways, your API gateways, things of that nature, to ensure that any service that's instantiated gets protected in the exact same means by the same policies at runtime when it emerges. Right? It becomes a very important, very critical piece, because as we move to distributed services, I don't necessarily know whether my API or my service is going to show up on GCP, on Azure, on AWS, on Oracle Cloud. So I want to make sure that anytime that it emerges, as soon as I can match that API, I'm also matching the policies that should govern the data that's feeding that API. Here's a very simple example using an open banking based CIBA flow, right? In this case, a user comes in and they authenticate, first of all, via TOTP or UID password at their bank of choice. They choose to then select a third-party payment provider. In this case, it's the Finicrew app on the left-hand side. So they go over there, Finicrew says, hey, are you going to consent to allowing us to see your data sets, right? And this, maybe it's an account number or first name, last name, for example. The user obviously consents. They try to perform a transaction. The Finicrew app says, well, to perform that transaction, because you're actually going to move data in this case, we want you to do a step-up authentication. And so they kick off the CIBA flow. That CIBA flow goes back over to an IDP or even to a separate IDP or to a separate authenticator and kicks off an MFA, in this case with FIDO. So now I authenticate to my phone. Everything's good. I pass that back along with my consent. I go back to the Finicrew app. The Finicrew app says, okay, your AMR record now says FIDO. Fantastic. You've consented to us utilizing this aspect of your PII data. We're going to process that, kick off the transaction, get the account balance, administer that data, and boom, you're ready to rock and roll. Again, this is all flowing over APIs, and this is a little bit of a simplification. However, this is how it's all fitting together to provide a very common user context using both dynamic authorization, step-up authorization in this case, your IDP, and then a FIDO-based authenticator, right? Leveraging all three of those things to secure your most sensitive assets, in this case, your PII, as well as your banking data. So how do we get there, right? And this is one of those big questions. And so we like to look at it, what's been done and where we have to go. And so if I look at what's been in the old world, right, I've been focused on long-lived sessions, business to employees, business to consumer business models, blanket privacy, where one click submits all, SAML, LDAP, things of that nature that just weren't designed for this multi-dimensional, multi-cloud distributed services landscape. And we move that into that new world. And what we're seeing, because of things like COVID, is the B2B2B or B2B2C or B2B2B2C business models are just exploding, right? Whether it's Postmates delivering food from our local restaurant, or whether it's Bank of America working with Wells Fargo and Mass Mutual to give you a comprehensive set of financial services in one portal. We also want to see things emerge like object and intent-based privacy. So no longer, right when I get to the front door of a website, do I click, hey, use my data for any and all intents and purposes. I want to be able to control how my data flows. I want to say, you know what, well, Bank of America, you can allow Mass Mutual to use my first name, last name, but only once, and once during the next 7 days. After that, please revoke. And so automating that with metadata surrounding the privacy and intent patterns. Obviously leveraging OIDC, OAuth, and FIDO as the standards for my next generation of application services, ensuring that I'm able to integrate those as quickly and simply as possible for distributed services, and then using things like authorization as code to supplement that, right? So am I in the right group? Have I submitted the right privacy claims? Is this service even allowed to talk to this other service? Ensuring all that gets wrapped up into a common framework. Leveraging next generation authentication for workload, moving beyond that static API keys, which you have to rotate every once in a while, to things like Spiffy, which have auto rotation and are PKI based, and will rotate your keys every 90 minutes, whether you mean to or want to or not. Getting past LDAP. We've all known since 1993 when LDAP was released, it wasn't designed as a multi-cloud or even a WAN-based distribution mechanism. So moving into distributed data stores and SCIM to ensure that we are able to progress and move our data securely and in real time across these multi-dimensional and multi-cloud data services. Lastly, get rid of the manual processes. If we're not automating it through things like DevSecOps, we're doing ourselves and our business a disservice. The developers are going to move with or without us as identity professionals. So let's make sure that we're giving them the tools, the guardrails, and the authorizations that they need to move this all into an automated infrastructure. Thanks for your time today. My name is Nathanael Coffing, again with Cloudentity. We're based in sunny Seattle, and please feel free to contact us directly if you have any questions.